Hey guys, and welcome to task 6.11. We are going to go through solving basic trig equations. We call these basic trig equations because they really are going to involve just a trig function on one side, cosine x, and a value on the other side. And that value is almost always, if not always, found on the unit circle. So look for these on the next 5 or 6 slides. Again, you're just trying to identify where this cosine equals 1/2. Now, if you check out your unit circle has a bunch of values of 1/2. We see 1/2 repeated a lot of times, sometimes positive, sometimes negative. And we need to think a little bit more intuitively before just hunting the circle. So let's think about cosine for a second. Cosine is the x-coordinate. So if I'm thinking about my unit circle, this side, or the right-hand side, is my positive x-axis. So in order for my x-coordinate to be positive, I can really only have angles of rotation on this side, on the positive x side. Why am I choosing positive? Because this isn't just 1/2, this is specifically positive 1/2. So in order for that to be positive, I need to find it here in quadrant 1 or down here in quadrant 4. So I'm going to have an angle that comes out in quadrant 1 or down here in quadrant 4. So when I go to hunt my unit circle, I now have a little bit of direction about where to go. I'm looking for an x-coordinate in quadrant 1 or quadrant 4 that equals 1/2. But let's be even a little bit more detailed about this. I know that my unit circle has a radius of 1. I'm looking for an x-coordinate of 1/2. So I really am going to look exactly halfway between the origin and the radius. So let's check that out. Here's our unit circle. Hopefully you're using your handwritten one. Let's go ahead and let's look on the positive half of our x-axis. Here in quadrant 1 somewhere, and here in quadrant 4 somewhere. And I am specifically going to kind of ballpark about halfway between. Well, if this is the origin at 0 and this is the end of the radius at 1, halfway between falls right about there. And so I didn't hit them exactly, but if you notice, I do hit pi over 3 and 5 pi over 3 pretty closely. Well, let's check. Our cosine is our x-coordinate. Both of these do have an x-coordinate of 1/2. And that makes sense because if I was actually thinking of these on a coordinate plane, they would be over 1/2. So there we go. We have two answers. One from quadrant 1, pi over 3, and one from quadrant 4, 5 pi over 3. So the answer to this would be x equals pi over 3. That was our result in quadrant 1. And 5 pi over 3. That was our result in quadrant 4. But let's try one more example. Let's ask this same exact question, but instead asking sine. What if we said sine x equals 1/2? Well, we have to think just a little bit differently because sine is our y-coordinate. So again, let's give ourselves some direction before just heading straight to our unit circle. If I know that sine is my y-coordinate, I can kind of decide which quadrants I'm looking at. Well, this is once again positive. It is positive 1/2. So I really just want the positive y values or the top half of our circle. Again, this is the positive y direction, so the top half of our circle is going to be our positive y values. So again, I want quadrant 1. That's going to be where I'm looking. And this time I want quadrant 2. So we're going to find an angle that pops out right here in quadrant 1 and a matching angle on the other side in quadrant 2. Now we're still looking at the value of 1/2, so it makes sense that it would be halfway between here at the origin and here at the radius. So we're going to look for something about halfway through. So let's go to our unit circle again, looking at quadrant 1 and quadrant 2. So we're going to look here in quadrant 1 or here in quadrant 2, and about halfway between the origin and the edge of our circle. Again, I just kind of ballparked where I thought halfway was, and it looks like my closest angles are right here at pi over 6 and the matching angle 5 pi over 6. Well, our sine value is in fact 1/2 at both of these. So those are the angles we're looking for. This is telling us that this rotation angle right here at pi over 6 has a sine value of 1/2, and this rotation angle right here at 5 pi over 6 has a sine of 1/2 also. So those would be our answers. So to finish this one off, we would say, where is the sine equal to positive 1/2? X equals pi over 6. That was our quadrant 1 solution. And 5 pi over 6. That was our quadrant 2 solution. Most of these will have 2 solutions. A few of them will only have 1 solution. So make sure that you're thinking about where to look for each problem. Now, you can think of it intuitively like I've shown you on these last 2 problems, or you can use a little kind of tactic that you might find on other tutoring sites or other websites, other resources. And it's an acronym. All students take calculus. What does that stand for? Well, which functions are positive in quadrant 1? They all are. Sine is positive, cosine is positive, and tangent is positive. They're all positive in quadrant 1. Which trig functions are positive in quadrant 2? Just the sine function. That's what the S stands for. And which trig functions are positive in quadrant 3? Just the tangent. That's what the T stands for. So I guess you can probably guess it at this point. Which functions are positive in the 4th quadrant? Cosine. That's what the C stands for. So you can think of it logically like I did, where this is our positive X, positive Y, negative Y. Or you can remember, all students take calculus. Okay, go forward to the next couple slides and solve some of these basic trig equations for yourself.